Now we have the question 8. In this question, we have a universal set eta that is equals to x such that x is a quadrilateral and two subsets, proper subsets of the universal set eta are A and B are given as follows. A is equals to x such that x is a rhombus and B is equals to x such that x is a quadrilateral with four equal angles. Now Q is a rectangle of the sides 12 centimeter by 10 centimeter. R is a rhombus such that two of its angles are 30 degree and 150 degrees. S is a square of sides 8 centimeter and T is a trapezium of sides 5 centimeter, 5 centimeter, 5 centimeter, and 9 centimeter. On the Venn diagram given below, write Q, R, S, and T in the appropriate subsets. So, before solving this question, first we will understand one concept. So here we will draw a rectangle for the universal set eta, and inside it we will draw two overlapping circles for the sets, say A and B, respectively. Now, the Venn diagram we have drawn is divided into four disjoint regions, and we will indicate those regions here. Those are R1, R2, R3, and R4. So, R4 is here.
So R1, R2, R3, and R4 are disjoint. It means that R1 intersection R4 is equals to phi. R2 intersection R4 is equals to phi. R3 intersection R4 is equals to phi. R1 intersection R2 is equals to phi. R1 intersection R3 is equals to phi. And R2 intersection R3 is equals to phi. So the regions drawn in the Venn diagram are disjoint.
So the concept we have discussed, we can easily apply that concept in the Venn diagram that is given in the question. So first have a look what is the quadrilateral is. Quadrilateral is a 2D shape with four sides and four vertices and four angles. Now let's see what is rhombus. A rhombus is a four-sided shape. All sides are equal, opposite sides are parallel to each other, and opposite angles are equals to each other. And the rhombus look like just this diamond shape. This is a rhombus. In the set B, we have a quadrilateral with four equal angles. So a quadrilateral with four equal angles is a square. Now what is Q? Q is a rectangle. So here Q is a rectangle having sides 12 by 10. So here we have 10. And here we have 12. Now let's see what is rhombus. Since we have seen the rhombus is a four-sided figure and all sides are equal and opposite sides are parallel to each other. So first we will draw the rhombus. Rhombus is just look like this. And two of its angles are 30 degree and 150 degree as given in the question. So here we have its two angles will be 150 degree and 30 degree, and they add up to 180 degrees. Now for S, S is a square of sides 8 centimeters, so all the sides in the square are of equal length. And T is a trapezium of the sides 5 centimeter, 5 centimeter, 5 centimeter, 9 centimeter. So trapezium is just look like this. And here we have a 5 centimeter, 5 centimeter, and 5 centimeter. And here is we have a one length that is 9 centimeter. So now we have to see that what is the relation between the P, Q, R, and S with the subsets of the universal set eta AB. So now we will write down the Q, R, S, and T in the appropriate subsets. So first we will see the relations. Since R is a rhombus and A is also a rhombus, but there is a bit difference between the R and A. Since R is a rhombus, such that two of its angles are 30 degree and 150 degrees. So this will look like this. Its adjacent angles will be added to 180 degrees. So one angle is 150 degree and one angle is 30 degree. So from this, R is a proper subset of A. Similarly for set S is a square and B is a quadrilateral with 4 equal angles. So it will also represent a square. So S is a proper subset of B. And since we know that A is a proper subset of A intersection B, and B is also a proper subset of A intersection B. So from this, S is also a proper subset of A intersection B. And by using this, we can also say that S is a subset of A, so it will also the subset of A intersection B. So from this, we can say that S is a proper subset of A intersection B. So we will write down S in the overlapping region. Now we have to find out about information R. R is a proper subset of A, so it will be written in the region 1. Now what about T? T is not a proper subset of set A or B, so it will be the subset of the universal set eta. So T is a proper subset of the universal set eta, and it will be written in the region R4. What about Q? Q is a rectangle of sides 12 by 10. So Q will be written in the region R3. In the question 9, we have a universal set eta that is equals to A, B, D, E, G, I, N, S, T, and U, and the three sets A, B, and C. A is equals to A, G, I, S, B is equals to E, I, N, S, T, and set C is equals to E, G, S, U. And since set eta is a universal set, and A, B, and C are the proper subsets of the universal set eta. Before drawing a Venn diagram, we will identify the regions A intersection B intersection C, A intersection B, B intersection C, and A intersection C. Since the sets A, B, and C are given, so first we will find out A intersection B. So we have to identify the elements in the sets A and B that are common to both the sets A and B. So we will underline the elements that are common to the sets A and B, and those are I and S. So A intersection B is equals to I and S. Now B intersection C. Now we will see the common elements in both the sets B and C. So E and S are the elements that are common to both the sets B and C. So B intersection C is equals to E and S. Now A intersection C. Now we will see the common elements in the sets A and B, and we will mark those elements with blue. So G and S are the common elements in the sets A and C. So A intersection C is G and S. Now finally, we have to find out A intersection B intersection C. Since it's the only element that is common to the sets A, B, and C. So A intersection B intersection C will be equals to S. Now to draw the Venn diagram, we will draw a rectangle that represents the universal set eta. And inside it, now we will draw 3 circles just because we have a 3-set Venn diagram problem. And these 3 circles represents the sets A, B, and C respectively. Now we will first identify the regions. This region is B intersection C. This region is A intersection B. This region gives us the information about A and B, but no information about the elements of set C. And this region is A intersection C. And the region here gives us the information about A intersection B intersection C. Now we will fill in the elements in the respective regions. Since A intersection B is I, so we will write down here I. And S will be written in the region A intersection B intersection C. The remaining elements in the set A will be A only. And the remaining elements in the set B will be N and D. Now B intersection C is E and S. So here we have E and S will be goes in the A intersection B intersection C. Now A intersection B is equals to G and S. So here we have G, and the remaining elements in the set C will be U. So this is the 3-set Venn diagram representation. That gives us the information about the different regions within no time. Now in the part 2, we have to find out A union B intersection C. Since the sets A, B, and C are given, the set A is A, G, I, and S, and the set B is E, I, N, S, and D. So first we will find out A union B. A union B means we have to put all the elements
together, so A union B is equals to A.
G, I, S, E, N, and D. And now we will take the intersection of A union B with C. So A union B is A, G, I, S, E, N, and D. And intersection the set C is E, G, S, and U. Now we will see the elements that are common to both the sets A union B and C. So we will mark those common elements with red. So they are G, S, and E. So the elements in the A union B intersection C will be S, E, and G. Now in the part B, we have to find out A intersection B union C. So first we will find out A intersection B. Since the set A and B are given, so we will have to identify the elements that are common to both the sets A and B. Since I and S are the elements that are common to both the sets A and B, so I and S are the elements of A intersection B. Now we will take the union of A intersection B with set C. So I and S union, what is the set C? The set C is E, G, S, and U. It means we will put all the elements together in the one set. So here we have E, G, S, U, and I. So A intersection B union C is equals to E, G, S, U, I. Now in the question 10, part A, we have the sets A, B, and C. The set A is equals to 1, 2, 3, 4, and 5, and the set B is equals to 2, 4, 6, and 8, and the set C is equals to 1, 3, 5, and 7. So we have to list all the elements of the set following. So the first is A union B union C. So have a look. First, we have to find out A union B. So it means we just have to put all the elements of the set A and B together. So first, the set A is 1, 2, 3, 4, and 5. Union, and the set B is 2, 4, 6, and 8. So by putting together elements of both the sets, we have 1, 2, 3, 4, 5, 6, and 8. So A union B is 1, 2, 3, 4, 5, 6, and 8. Now we have to find out A union B union C. A union B is 1, 2, 3, 4, 5, 6, and 8. And the set C is 1, 3, 5, and 7. Now we have to put together the elements of both the sets in one set. So here we have 1, 2, 3, 4, 5, 6, 7, and 8. So A union B union C is equals to 1, 2, 3, 4, 5, 6, 7, and 8. In the part 2, we have to find out A union C intersection B. For this, first we will find out A union C. The set A is 1, 2, 3, 4, and 5. Union, and the set C is 1, 3, 5, and 7. So we just have to put the elements of both the sets together. So here we have 1, 2, 3, 4, 5, and 7. So the A union C is equals to 1, 2, 3, 4, 5, and 7. Now we have to find out A union C intersection B. So the set A union C is 1, 2, 3, 5, and 7 intersection, and the set B is 2, 4, 6, and 8. We have to pick the elements that are common to both the sets. So those elements are 2, and 4. So A union C intersection B is 2 and 4. Now on the part B, we have given that D set is equals to A, B, C, D, E is equals to A, B, C, and F is equals to A. We have to find out D intersection E union F. So first we will find out E union F. The set E is A, B, and C, and the set F is A and E. So A union F is just like putting the elements of the set E and F together. So here we have A, B, C, and E. Now we have to find out D intersection E union F. Since the set D is A, B, C, and D, intersection E union F is A, B, C, and E. So we just have to find out the elements that are common to both the sets, and those are A, B, and C. So during intersection, E union F is equals to A, B, and C.
Now in the question 11, shade the following regions on separate Venn diagram. So here we have a universal set eta and having two proper subsets A and B. And since we can see that the sets A and B are the overlapping sets, so in the part 1, we have to find out the shaded region for the A union B complement on a separate Venn diagram. So for this, we will split our operation in different steps. First, we will find out the region for the set A. So for this, we will draw a rectangle. For the universal set eta, and inside it, we will draw two circles, two overlapping circles. That represents the sets A and B respectively. Now we will use the color red to represent the area for the set A. So this is the region for the set A. Now we will draw another Venn diagram. This is the Venn diagram for the set A only. Now for the B complement. We will draw a rectangle that represents the universal set eta. And inside it, we will draw again two overlapping circles representing the sets A and B respectively. Now, what is meant by B complement? So excluding the set B, we will shade the remaining regions. It includes the region of set A and the region of the set eta. Now in the third Venn diagram, this is the Venn diagram for B complement. Now for the Feynman Well diagram, we will draw a rectangle that represents the universal set eta. Inside it, we'll draw two overlapping circles representing the sets A and B respectively. And we will use this Venn diagram to find out A union B complement. So for this, we will put together all the regions in the first and second Venn diagram. So we will put all the regions together just because we want a union. So A union B complement is represented by the region shaded red in the third one. Now in the part 2, we have to find out A intersection B complement. So for this, first we will find out the shaded region for the set A. So here we draw the first Venn diagram. We will draw a rectangle for the universal set eta. Inside it, we will draw two overlapping circles representing the sets A and B respectively. So for the set A, we have to shade the region with red color. This represents the region for the set A. Now in the second Venn diagram, we will draw again a rectangle for the universal set eta. And inside it, we have two overlapping circles representing the sets A and B respectively. And we will shade the region for B complement with black, excluding the set B, and we will shade the remaining region with black color. So this is the region for B complement. Now in the third Venn diagram, we have to find out the region for A intersection B complement. For this, we will again draw a rectangle that represents the universal set eta. So here we have the region that is common in both the Venn diagrams is the region in the set A only. So the third Venn diagram represents the shaded region for A intersection B complement. In the part 3, we have to find out A union B Hall complement. So for this, we will draw a rectangle for the universal set eta. Inside it, we will draw two overlapping circles that represents the sets A and B. So we have to find out the region that that represents A union B Hall complement. In other words, the region that is belongs to the set eta only, but does not belongs to the set A union B. So we will shade the region that does not belongs to the A union B. And this is the region that belongs to the set eta. So the region shaded in red represents the region for A union B Hall complement. In the part 4, we have to find out the shaded region for A intersection B Hall complement. So for this, we will draw a rectangle that represents the universal set eta.
Inside it, we will draw two overlapping circles that represents the sets A and B respectively. Since we know that what is meant by A intersection B, the region that represents the A intersection B is not but the overlapping region. So but what is our requirement? Our requirement is that the region that belongs to the set eta, but that does not belongs to the set A intersection B. So we have to exclude the overlapping region and shade the region of the set eta and the set A only and the set B only. So for this, we will use the red color to shade our required region, just like this. So the region shaded in red represents the AU intersection B Hall complement. Now in part 5, we have to find out the shaded region for the A complement union B complement. So first we will find out the region for the A complement. So for this, we will draw a rectangle that represents the universal set eta, and inside it, we will draw two overlapping circles for the sets A and B respectively. Now we have to find out the region for the A complement. So for A complement, we have to exclude the set A and shade the region of the set B and the set eta with red color. So for this, we will shade the region of set eta and the region that represents the set B, excluding the set A. So this is the region for. So this is the Venn diagram representation for A complement. Now we have to find out B complement. For this, we will draw another rectangle for the universal set eta. Inside it, we will draw two overlapping circles representing the sets A and B. And the B complement is represented with the help of black color by shading the region for the set eta and for the set A only. So the region shaded in black represents B complement. Now in the third Venn diagram, we have to put all the regions together in the first and second diagrams. So here we have two overlapping circles representing the sets A and B respectively. And now we will put all the regions, shaded regions of first and second Venn diagram and the third Venn diagram. So here we have the regions that shaded in blue.
represents the A complement union B complement. Now in the part 6, we have to find out the shaded region for A complement intersection B complement. Since in the part 5, we have find out this region for the A complement and B complement for in the different Venn diagrams. So now we will draw a rectangle representing the universal set eta. Inside it, we will draw two overlapping circles for the sets A and B respectively. And now we have to take the region in the third Venn diagram that are common in the first and second diagram. So the region that is common in the first and second diagram are the region of the set eta only. So the region shaded in blue represents the set A complement intersection B complement. In the part 7, we have to find out the region, shaded region for the A complement union B Hall complement. So for this, first we will find out the A complement in the separate Venn diagram and B on the separate Venn diagram. So first we will find out A complement. For this, we will draw a rectangle that represents a universal set eta. Inside it, we will draw two overlapping circles that represents the sets A and B respectively. Now we will exclude the set A and shade the remaining regions in the Venn diagram with the red color. So the region shaded in red represents the set A complement. Now for the set B, we will draw a rectangle that represents the universal set eta, and for this we will draw two overlapping circles inside the rectangle representing the sets A and B respectively. And now we will shade the region for the set B with black color. And this represents the region for the set B. Now in the third Venn diagram, we have to draw another rectangle that represents the universal set eta. Inside it, we will draw two overlapping circles representing the sets A and B respectively. And now we will shade the region with a red color for the A complement union B. So we have to put all the regions in the first and second Venn diagram in the third Venn diagram. So for this, we have the region shaded in red in the third Venn diagram. Represents A complement union B. But our aim is to find out A complement union B Hall complement. So for this, we will draw an rectangle that represents a universal set eta. Inside it, we will draw two overlapping circles that representing the sets A and B. And now we will shade the region for the A complement union B all complement with blue color. Since the region for the A complement union B is the region that is left in the third Venn diagram. So the region left in the third Venn diagram is for the set A only. So this represents A complement union B Hall complement. Now in the part 8, we have A union B Hall complement. So for this, we will find the region for the set A and the B complement in the separate Venn diagrams. For the region for the set A, first we will draw a rectangle that represents the universal set eta. Inside it, we will draw two overlapping circles that represents the sets A and B respectively. Now we will shade the region for the set A with red color. Now for B complement, we will draw another rectangle. This represents the set A. Now for the set B complement, draw another rectangle that represents the universal set eta. Inside it, we will draw two overlapping circles that representing the sets A and B respectively. And we will shade the region for the B complement with black, excluding the set B. And we will shade the region of the set eta and the set A only with black color. So this represents the region for the set B complement. Now we have to find out the region, the shaded region for the A union B complement. So for this, we will draw again another rectangle that represents the universal set eta, and inside it we have two overlapping circles A and B. And for this, we will put the all shaded regions in the first and second Venn diagram here. So we will use the black color to shade the region for the A union B complement. So here we have this region. Now we have to find out A union B complement Hall complement. So for this, we will draw another rectangle that represents the universal set eta. Inside it, we will draw two overlapping circles representing the set A and B respectively. And now we will use the blue color to shade the required region. So the region that is missing in the Venn diagram below is the set B only. So this represents this Venn diagram shaded in blue represents the shaded region for A union B complement Hall complement.